Good morning. Last time we started to talk about simple regression. So today we are going to talk about regression analysis and hypothesis testing. Last time we said that there are 5 main questions we have to answer regarding any relationship we would like to study. Say for example, I equals 100 minus 0.3 I. From this equation, we would like to identify what are the answer for the 5 main questions. Number one, what are the variables under consideration, or what are the variables we would like to study the relationship between them? They are investment and interest rate. Investment is the dependent variable, and interest rate is the independent or explanatory variable. Question number 3. What is the value of the dependent variable if the independent variable is 0? It's 100. Value of I if interest rate is 0. Question number 4. What is the change in the dependent variable if the independent variable changes by 1 unit? So it is 0.3 if interest rate increase by 1, investment will decrease by 0.3. And finally, whether the relationship is positive or negative, it's negative relationship between interest rate and investment. So these are the 5 main questions. And we have differentiated between population and sample using notations. As we said, population, equation for population can be written as y equals alpha plus beta x plus u. So this is related to population. It's equivalent to y equal a plus bx plus e. This is for the sample. So if you are going to deal with the whole population, you can write the equation in this form. But if you are going to deal with a small sample, so we can write it using this form. And as we said that in economics, usually we use a sample instead of population due to data limitation. Also, we have differentiated between actual and estimated values. And we said that actual values can be written as y equal a plus bx plus e. But after estimation, the estimated equation will be y hat equals a hat plus b hat x. And the error can be calculated as the difference between y and y hat. This can be represented graphical by the best fitted line y, x and y. This is the best fitted line, best fitted line, which represent this equation. And we have, this is the actual values. The difference between the actual and the estimated value is the error term. It has positive values and negative values, so summation of error will be 0, as positive values are going to offset the negative values. Let's take an example. We would like to estimate the parameters as we did last time. If you are given the following, this is y and this is x, 2, 4, 8, 7, 8, 10, 8, 5, 4, 3, 2, 2. Required is to estimate the parameters, where y equals a plus bx plus e. So now we have to find the value of b and e. B hat is calculated as xy bar minus x bar y bar and divided by x squared bar minus x bar squared. So we have to calculate x bar, y bar, x square bar, xy bar. Bar means the mean. The mean of anything is calculated as its summation over its number. Okay, so here we have to add x squared, xy. It's calculated as x squared is 64, 25, 16, 9, 4, and 4. xy 16, 20, 32, 21, 16, and 20. This is summation for each one of them. It will be 39, 24, 122, and 125. If you would like to find x bar, it's going to be divided by the number. It's the number 1, 2, 3, 4, 5, 6. It's 6 observations. So the mean will be 96 divided by 6, 24 divided by 6, 122 divided by 6, 125 divided by 6. So this is 6.5, this is 4, 20.33, and 20.83. Now we are going to substitute in the equation in order to find the value of b hat. 20.83 minus 6.5 multiplied by 4 divided by 20.33 minus 4 squared. The value is negative 1.19. Now we are going to use the estimated value of b hat in order to find the value of a hat. A hat is calculated as y bar minus b hat x bar. Y bar is 6.5 minus negative 1.19 multiplied by 4. So it will be 11.27. So now we can write the equation as y hat equals 11.27 minus 1.19x. This is the estimated value of the equation. From this, we can answer the 5 questions that we would like to study the relation between y and x. Y is the dependent, x is the independent. If x is 0, y will be 11.27. If x increases by 1, y will decrease by 1.19. There is a negative relationship between x and y. Also, we can find the estimated value of E hat. E hat is calculated as y hat minus y. Y hat means that we are going to substitute using the values of x in this equation. So this is y hat, which is calculated as, say for example, for the first point, it will be y 11.27 minus 1.19 multiplied by 8, multiplied by 5, multiplied by 4, and so on. So the value will be 1.73, 5.3, 6.5, 7.69, 8.88, and 8.88. If you would like to find the estimated value of E hat, it's going to be calculated as y minus y bar, y minus y hat. So it's 2 minus 1.73 and so on. It is 0.869, negative 1.31, 1.5, negative 0.6, 9, negative 0.88, and 1.11. If you are going to add all of them together, it will be 0. Now we are going to move to the second part of our lecture, which is hypothesis testing. What's meant by hypothesis testing? Hypothesis testing means that after estimation of the model, you would like to make sure that your estimation is correct, is reliable. You can rely on the results estimated in the model. So here we are going to test for the reliability of the model. With respect to hypothesis testing or estimating reliability of the model, we have a number of tests or measures that can be used. Number one, t-test or t-ratio. Number two, r-squared, or known as coefficient of determination. And number three, f-ratio. T-ratio is related to parameters. So this means that t-ratio will be implemented for each parameter alone, while r-squared and f is related to the model as a whole. Reliability is measured by standard error. So let's start with the first one, which is t-ratio. The main idea of hypothesis testing that we have a hypothesis. It can be true or false. Just like if I said that interest rate has a negative impact in investment. It can be negative, it can be positive. So it can be true or false. This is just like a true or false statement. So we can write the hypothesis as H node, which is known as the null hypothesis, and H1, which is known as the alternative. H node B equals 0, which means that B has insignificant impact. Equals 0 means it's not 0. It's not, the actual value is not 0. It is equivalent in the meaning. it has no significant impact, just like nothing. Okay. The alternative B, not equal 0, which means has a significant impact. So we are going to do the same for A and B. And if there is any more variables, we have to conduct the hypothesis testing for each one of them. T ratio is calculated as the value of the parameter divided by its standard error. If it's B, يبقى B divided by standard error. A divided by its standard error. So now we would like to know how to calculate the standard error of each one of them, A and B. Standard error of B hat is calculated as square root sigma squared divided by summation small x squared, or can be written as sigma divided by square root summation small x squared. What's the small x? Any small value, small notation, means deviation from the mean. So if we would like to find the value of sigma and small x, we can write it as small x means x minus x bar. This is a small x. And if you would like to find the square value, so you have to have two different columns. It is x minus x bar, and this is x minus x bar squared. And then you are going to add all of them together to find the value of summation x squared. What about the sigma? Sigma is calculated as sigma squared is calculated as summation e squared divided by n minus k. What's n minus k? N minus k is known as the degrees of freedom. N stands for number of observations, and k is the number of parameters. Okay, if you would like, we would like to use the same Okay, let's take the same example. Okay, so here we have to add x minus x bar and x minus x bar squared. So x bar is 4, so it's 8 minus 4 is 4, 5 minus 4 1, 0, 3 minus 4 1, 2 minus 4 2, and 2 minus 4, sorry, negative 2 and negative 2. This is negative 1. Squared value, it's 16, 1, 0, 1, 4, and 4. So summation it's 25. Sorry, 24. 24. So now we have the value of of summation x squared, which is 24. Now we would like to find the value of sigma squared. Sigma squared is summation e squared divided by n minus k. So we have to calculate e squared. This is e, so we have to calculate the squared value of each one of them. We have to get the squared value and then find the summation of all of them. It will be 6.538. So now we can substitute in the equation as sigma squared is calculated as summation e squared divided by n minus k. Summation e squared we have calculated as 6.538 over number of observations is 6 and number of parameters, we have two different parameters, a and b, it's 2. So sigma squared will be 2.179. We are going to do the same with respect, now we have to substitute in standard error of b hat, which is calculated as square root sigma squared divided by summation small x squared. Square root 2.179 divided by summation of x squared we have calculated as 24. So the final answer will be 0.295. So now we have to calculate the t ratio. T is calculated as T of b hat is calculated as b hat divided by standard error of b hat. B hat is we have calculated b hat as negative 1.19 divided by standard error of b hat, which is 0.295. So the final value is negative 4.038. So this is the value of the t ratio. We have to compare the value of t calculated with t tabulated. Or for simplicity and right now, we are going to assume any value greater than 2 to be significant. The absolute value as the negative sign stands for the negative relationship. So this is 4, which is greater than 2. This means that we are going to reject H node, which means that the value, the parameter has no significant impact on Y, and accept H1, which means that interest rate has a significant impact on investment, or the explanatory variable has a significant impact on the dependent variable. So once again, we would like to find the value of t of b hat. It's calculated as b hat divided by standard error of b hat. Standard error of b hat is calculated as square root sigma squared divided by summation small x squared. Sigma squared is calculated as e squared divided by n minus k. then we have to take our decision whether the variable has a significant impact or not, or whether we are going to accept each node or not. Now I would like you to do the same with respect to A. T ratio of A is calculated as A hat divided by standard error of A hat. But there are some changes with respect to standard error of A hat. It's calculated as square root summation x squared sigma squared x squared multiplied by sigma squared divided by n small x summation small x squared. So this means here we have to add summation. This is the capital letter, not the small letter, and here we have to add n in order to find the value of standard error of A. Anything else is the same. So with respect to sigma, it's calculated using the same rule. Small x, it is large X minus X bar. So now I would like you to do this by yourself to find the value of T for A hat, T ratio for A hat, and to identify whether it is significant or not. This is the end of our lecture today. Thank you and see you next week.